Thanks everybody for joining us today. My name's Ed Gash. I'm the account manager and business development manager here at Mobilize, and I'm joined by my colleagues Gareth Davies.
Hello.
Mark Williams.
Hello.
And Nick Gowtry.
Hello.
And today we're going to a bit of an informal format, kind of like a bit of a deep dive, talking about data lakes, some of the different use cases that we've seen, as we're helping customers implement these technologies. Mobilize, we are a cloud consultancy, cloud enablement company, helping organizations, whether it be public sector or private sector, using services from like AWS, Google, Microsoft, both on the cloud side and also with things like the vendor managed AI services. So I guess starting off, an introduction, as we're talking about data lakes, I guess we can't really talk about data lakes without talking about big data, would you say, Gareth?
Yes, so big data is a coin that was termed maybe, quite a while ago now, maybe 15 or so years ago. And I think immediately when you think of big data, you start thinking about kind of, large files that you're having to process and that kind of thing. But big data really is describing a kind of problem that we have with processing a ton of individual data sets. So within the next 5 years, there's estimates that we'll have 175 billion terabytes stored on servers around the world. And I believe I read something along the lines of 90% of the data that's now available was only created in the last 2 years. So, with those facts, we're looking at a huge rate of increase in the amount of data that's going to be available to organizations and businesses. And part of that is being kicked off by the invention and the predominance of 5G and how that's going to onboard a whole new set of devices. I think previously we were looking at the Internet of Things, and maybe, I don't know, 5 to 10 years ago, we were promised that our fridge would be able to order food for us when some milk ran out. That hasn't really happened yet. But with 5G coming, you're going to have a lot of connected devices coming online. So, for example, if you imagine a traffic light system, you're going to have devices on those traffic lights that can shape the way traffic is coming through and optimize traffic. There's going to be devices on the cars that interact with those. And then when you're passing a shop, there's going to be devices on the shops that send nice friendly advertisements to your phone as you go by. So with all these new devices, each device is going to be reporting, streaming information maybe every second. So you're going to have a ton of metric information that's available. So the challenge is with big data isn't really about how much data you can collect, but it's about how you process it, analyze it, and interpret it. So
yeah, I mean, I think there's been a shift within organizations over the last 10 years, or at least, it's definitely accelerated a lot in the last 5 years around people understanding that there is value in their data and, that they need to be using it more effectively to remain competitive.
Yeah. So data is becoming at the forefront, like you said, of an organization's priorities. And so the challenge, the general kind of challenge towards organizations nowadays is how do they take data from their multiple sources within their business and kind of leverage it to do things like produce cost reductions, to increase product development and innovation, or to make informed decision making on things like marketing campaigns, and also time savings on business processes. So how can we get data out of traditional kind of siloed databases and move it all together so we can analyze kind of joint data sets?
So I guess this is sort of where the data lake comes into it, isn't it?
Yes, yeah. So if we're looking at data lakes, what essentially what is a data lake? it's kind of a large repository where you can store all of your structured and unstructured data. And that's one of the key components, is that you can store this unstructured data. So, traditionally with a database, when you're putting data into the database, you know the format it's got to be in, you know the schema, you know exactly, or around, have a good idea of what you're going to do with that data. Whereas a data lake is kind of designed so that you can put your data, you can amalgamate your data from lots of different sources and store it kind of independently to the compute layer and to the data type layer. So when you're uploading your data to the data lake, you don't need to know upfront how it's going to be used. You just know that this data could be valuable in the future. So let's start storing it and let's open it up to let other people use it. So some kind of important data lake characteristics are things like diverse interfaces, so lots of APIs and endpoints for interacting with the data lake, and that's because you're going to have a lot of different ways into the data lake, from things like legacy data sources, even people manually uploading data. You're going to have cloud resources connecting to that data lake, so it needs to support a lot of use cases. Another kind of aspect is a sophisticated access control mechanism. So if you imagine your company is starting to pull all of this data together, it's a very valuable data source. So you need to protect it and ensure that only the right people get access to the right parts. Another feature would be the ability to search and catalog that data. So you need to increase your kind of metadata. So as you're putting data into the data lake, you need to describe what data it is. Because if you imagine you're storing, gigabytes, even terabytes of data, you need to be able to navigate through your data lake to be able to find what you need to find when you need to find it. And kind of finally, another kind of major characteristic is the support for analytical processing. So the ability for your data lake to open up and let cloud analytical services in to analyze and produce kind of reporting and metric information on that data. And then I guess there's a question is, well, I've heard a little bit about data lakes, but what about data warehouses?
Well, yeah, I mean, that's what I was going to say. It's kind of like you can still do a lot of this stuff with a data warehouse. How does it kind of differentiate?
So to go back on my point, the point about a data warehouse or a database in general is that your structure beforehand. So there's kind of this step before you can do anything with your data where you have to plan and design how you're going to store your data. The relationships between tables, that kind of thing. And data warehouse is it's optimized towards relational data coming in from transactional systems. So when you're trying to collect data from across your business, it might not suit that case. So the data lake is different because you can store relational data from things like databases. So you can have exports from databases going into your data lake. But the important thing is it also stores unstructured data. So things from IoT devices, mobile apps, and that kind of thing. So it's not really a question of data warehousing versus data lake. You can use both in conjunction. So a common pattern is to use a data lake to kind of capture all the data in its raw format before it's kind of subjected to some transformation and then loaded into a data warehouse. So your data warehouse can be a kind of subset of your data lake. So you can still do all of the good things that data warehousing lets you do. It's just another step in the chain so that you have that raw data available for other uses as well.
Yeah, I mean, I've come across customers that have said similar things, or have, put in similar scenarios when, they've just found trying to process natively on the unstructured data has just been painfully slow. So, once they actually identified what was useful from within that data for that use case, building more of a traditional data infrastructure around it to support that need actually helped speed up the processes to a more workable Great.
Yeah. Yeah.
I mean, I guess this next one is, probably what I see this has been a huge game changer within the industry around general adoption of data lakes. I mean, I remember, only like 5 years ago, you would be looking at companies or organizations trying to set up their own data lakes, whether it be using something like Hadoop or different services, and it was always an overly complicated, very expensive, and a lengthy process, which kind of meant that a lot of these projects never really got to the point of actually realizing the benefit of using a data lake.
Yeah. Sorry to butt in, Ed. I don't know if it's just me, but my slides aren't changing on my screen.
Oh. Okay, I think this is.
It's the same for me as well, Ed.
The delights of
live webinars.
Yeah. So hopefully you're able to see. Are you able to see that now?
Yeah.
Let me see if I can put it back into present mode again, and if there was any. No, it's doing it. I think I'm just going to have to do it. I can't use present mode on Zoom, which is always fun. So yeah, talking about the data lakes, and basically the cloud offered service, or the managed data lakes. I think this really helps. Really helps companies quickly adopt and experiment with this type of technology.
Yeah, so by having kind of these managed services do a lot of the heavy lifting for you, it does let you rapidly build up data lakes, very quickly. Within a matter of hours, you can set up, a fully fledged data lake. Some do it better than others. I think, for example, there's Amazon's AWS Lake Formation, and that basically gives you a kind of wizard that you can step through to create your data lake, and it ties everything quite nicely together. So that's an interesting one to look at as well.
Are we going to have arguments between like Mark saying no, he prefers the Azure one?
I think so, yeah.
No, I think, as Gareth mentioned, all the providers that we deal with have some way of automating some of the deployment of some of these tools, or they have some sort of template in place already. We know Microsoft Azure has some IAM template in which you can use to deploy some of these for some of these components. And Amazon Web Services, as well as having that lake formation, you can also use things like the cloud formation templates to deploy some of the infrastructure there for you. I'm not too familiar with the Google side, but I know they do a similar sort of thing with some of the automated tools and automated deployments that they have as well.
Yeah, I mean, I guess with it being in the cloud, you get the same cloud benefits as as moving like traditional infrastructure in there.
Yeah, and the other thing is with this now, data lakes and artificial intelligence and these sorts of components, is that the competition between, let's call them the big three, is so big at the moment that it's really pushing the progress forward, and they're developing new tools and new components really quickly.
Yeah, I mean, I know it's reInvent this week, and I'm sure there will, or I say this week, the next couple of weeks, the big AWS conference, which is virtual, but I'm sure there's going to be huge developments within the, not only the data lake side of it, but also in the, the managed AI services. Like you said, it's a hugely competitive battleground for the big three at the moment.
Yeah, and what it also lends itself towards is I guess, as the slide suggests, is that when you're using these data lake services, you're already building on top of established cloud technologies that have been around for years. So things like the speed and scalability. So the data lake will be built, whether it's on AWS, GCP, or Azure. It's built on top of their kind of object storage technologies, which are extremely cheap, extremely durable. So the SLAs that some of the providers offer are 99 point and then another 11 nines of percentage of availability. So when you can be confident when you're storing this data in the cloud that it's going to be highly available, it's going to be replicated across things like availability zones so that you have backup copies of it, and all of that is done automatically behind the scenes as part of the service. And another point is it's all pay per use, so there's not this big commitment up front that you have to kind of invest in licensing or offer any kind of payment up front. It's all pay per use. That's both for the storage and for the queries. So you can experiment as little or as large as you want to, and you could just trial something for a couple of weeks and throw it away and pay a couple of dollars for the whole thing.
Yeah, I think that's a really key point, because I think it's really easy for us to forget that it's not that long ago that just to build an application server in an on-prem setting, you'd be having to get full budget sign off, and before when you've come to just the proof of concept phase, let alone actually deploying it. So yeah, that whole thing of being able to turn it on, turn it off, only pay for what you need, lets you experiment more and be a bit more agile and kind of without the penalties. And if things don't, if you don't see the benefit, well, you've probably spent $10 or $20 of service cost. It's not a huge deal.
Yeah, I think fairly recently we set up a proof of concept for a client, and it was, I think we had about, we'd imported an Oracle database into with about 1,000 tables into AWS's data lake. We had about 5 users querying that data, and we had a couple of dashboards in QuickSight. And I think our bill was coming to round about, I think it was less than $150 a month for a couple of months. So when you're talking about sort of proof of concept costs and no upfront outlay for anything at all, just pay for what you use at the end of the month, you could, $150 in the vast scheme of things for something like that is nothing compared to even what it would cost you if you just had to buy disk space for an on-prem solution.
You couldn't get SAN storage anywhere near that cheap, let alone the compute to go in front of it as well.
Yeah.
So I guess, data lakes are all great, but and like Gareth said earlier on, it's one of those that you've got your data in there, but then you've got to do something with it. And I guess that's the bit that really helps you drive value from the data lake. I mean, as you can see, there are not millions, but there are thousands and thousands of tools. I think if we just look at a couple of the key the key ones and what some of those differences are in the way that you use them. So I know that Gareth, you were talking earlier about sometimes you would want to do more of a traditional ETL process to set up a standalone if you're exporting out into a separate data warehouse or database. But I guess there's also the option that you can do it on the fly straight out of the data lake. So you do more of this ELT process, not ETL.
Yeah, so I guess one of the core concepts behind a data lake, which we'll touch on a little bit later, is the fact that you store your data in its raw format, and you get that by extracting it from a particular data source within your business, for example, or maybe it's an IoT feed from a sensor that's coming in. So you extract that data and then you load it into your data lake, and that data remains as it is in its raw format, so that you can in the future transform that data however you like. So maybe traditionally in a database format, your data would come from its source. It would be loaded into the database. As you're doing that load, you're transforming it to fit into the schema of your database. So you kind of already in that step, you've lost the raw data. So if you wanted to come back at some later point and do something else with the data, you're kind of stuck with whatever you've transformed it into that database. So if you're doing it the other way around, doing ELT and loading it into the data lake before you do your transformation, you've got that raw data forever, to be able to do with it what you like in the future. And what on this slide, we're just showing the kind of vast tools that are available in the cloud to do all this heavy lifting for you. So there are tools that do this extraction, such as Azure's Data Factory. So that's a managed service which can reach out and connect to your databases and automatically pull in data. It's built with hundreds of different connectors to connect to loads of different data sources, including software as a service data sources, and loads of other things. The loading step, you can use things like Google's Cloud Data Fusion, so that can load data into the data lakes. And then your transformation just picked up on AWS Glue, so that can catalog all of this data and the metadata that comes along with it, and it uses serverless functions to do that transformation. So when we say serverless function, that's your infrastructure is being managed by the cloud, and you don't have to worry about when to turn it on and off or how much you need to provision. It's all managed behind the scenes for you, and that's one of the big plus points for data lakes in the cloud, is that the majority of these services are serverless, so you don't have to support, maintain, patch, or build any of the surrounding kind of infrastructure that would do this work in a data lake. It's all taken care of for you. And then finally, your kind of presentation software, if you're going down the route of presenting this data in the form of reports, you can use things like Microsoft Power BI, which now has built-in machine learning to automatically generate dashboards for you and insights.
I think one of the other things that's really interesting as well with some of this transformation and presentation of the data more than anything else is the way that a change in the data or the load of the data can cause a triggering of that transformation. So if you are getting a data feed in once a month, then that maybe just once a month is enough for you to get that data transformed and presented in Power BI. But if that data was coming in every half hour or once a day, you can change the transformation on that single data source so that your Power BI reports or your Power BI presentations are up to the minute or up to the day with live data as well. I think that was probably something traditionally would take a longer time, is to get that data into a data source where it's been transformed and you know that the data is good.
I mean, talking about additional tooling there, all these data lakes, it's quite often, we think of data scientists accessing these, accessing the data, and, they have their favorite tools, whether it be Python or R, or, if they want to use something like Spark. But then, I think one of the, again, another interesting service, and you touched on it a bit earlier, Mark, was, how all of these services, or all of these tools are again available on demand, pre-built machine learning models, or with even some of the automated training set up in these vendor offered products. So whether it be in Microsoft, Google, or AWS, they've all got different toolkits that can help you accelerate this, and also kind of not need such niche or skilled resources to handle that. Would you say that's fair?
Yeah, absolutely. And also you have a lot of sort of templates as well in there for some of these transformation jobs. So I think it's AWS Glue that has some transformation templates for your data. So it can go off and look at your data, categorize it, and come up with some recommendations about which sort of templates and which transformations you would use. based on what it can see from the metadata.
I guess another benefit as well is the whole thing of once you've got your data sitting in your cloud, your data lake in the cloud, you can then just bolt on pretty much any service on top of that. So, if you are wanting to use that data for a real-time update to an alerting platform, or something else altogether, you can then just build connections between the environments, but everything is already in AWS or everything is already in Microsoft, so you can then just build on with those additional tools. Yes,
and you've got that tight integration of security as well, and control about access, because you are sharing some of the access management tools between some of these components. I think as well with the 3 suppliers is you can do things like you can spin up something that they call like a notebook, which really allows you to do some interactive development of some of the ETL scripts then, and bring some of your own scripts which you may have got from your on-premise into the cloud environment. So you can expand on the included scripts, create your own in a different in different languages as well, whichever one is the one you prefer. There's a lot of Spark and Python and R code in there. The integration as well, like you say, Ed, is by using the components from that supplier, you also get the security and the speed as well, because they're all on the same backbone effectively. So you were getting that secure, fast environment spun up.
Yeah, I guess there's no when you think about big, large enterprises where, they've got data centers all over the place, and, running the jobs could mean, using data in a different, in a totally separate location, whereas at least you can kind of, if you're still doing it within the same region, or, or in the same, the same region, that would help with latency and so on.
Yes.
So I guess the other part as well is once you've done all of your clever stuff, whether it be machine learning, whatever it might be, I guess the key value that comes from data lakes is just insight in some way, and being able to plug in dashboarding technologies to make it more easily understandable to common folk like me, rather than technical users, is also a benefit as well.
Yeah, I think that's important to point out, is that you will have different users of these systems. You will have your data scientists, and you will have the people who just want to look at the data in a nice format at the end to make some management decisions, or even to look at some trending. The slide you've got up at the moment that's a slide from AWS QuickSight. There's another one which will follow shortly, but this was a data set that I picked up from a government website, and I only picked it up this morning. I loaded, it's the London Borough COVID cases, which is quite topical at the moment. So I grabbed the government data on this morning. I stuck it through the AWS environment to put it into a data lake, and set up this very quick dashboard just to show the number of cases by area and date in some of these images. Literally, that took me about 10 minutes to create a dashboard. And it took
well, I mean, it's interesting that you say as well that you set up the AWS data lake as well, just so from a experimentation point of view. Whereas like here you're just wanting something to to show in a on a webinar, but if you were just wanting to experiment with something, it's really rapid development environment for these types of things.
Yeah, I mean, as well as this includes that bottom right hand corner, includes what AWS call insights, That's not a slide that I've created. That was one that the system itself has created by looking at the underlying data. And it's just picked up sort of some key components or some key figures from some of the data, and it can give you its interpretation of that data. So it will look at the data and say, oh, actually, what might be interesting to you is the top number of cases of COVID for December, and it can give you that without you actually having to go through and create that sort of insight. It does it for you.
That's really powerful, really impressive.
Yeah.
I mean, what's the other one here? Is this?
So this is again Power BI, and again this was taken from this was actually taken from the data that we've put into AWS. So it's the same data source. It's just showing images at some different types of graphs that you can see and some other ways of displaying the data. But again, what I've put in this one on the top right-hand corner, that sort of narrative that you can see, that again is business intelligence and machine learning showing that. So again, I pointed it at a data set, and it's sort of gone away and said, oh, look, the longest period of growth in new cases was between March the 9th and April the 2nd. And that's nothing to do with how I've set the dashboard up. That is asking the tool to give me some insight into the data. So it's really interesting how you can look at some trends. It does things like recommendations based on, so if you were a business involving sales, it can look at your sales and trend the sales, say, coming up is a busy month based on trend, therefore we need to increase our supply, or we need to get more supply in for demand. So all those sorts of things give you a bit of a insight into the business and improving business decisions effectively.
Yeah, I mean, the whole thing of making data-driven decisions is is really key, and it is a really common trend that we're seeing with multiple customers right now, if they haven't already. I guess something you did touch on a little bit earlier, Mark, was talking about data lake security. I mean, I know, this is kind of the AWS standard shared security model, but I guess it's interesting to show what is still covered for you, and guess where the gaps are that you need to think about for yourself.
Yeah, so I guess what we're trying to show here is that maybe when we were speaking to customers maybe 4 or 5 years ago, there was this unsure narrative about loading their data into the cloud. So what this shows is, and this is just for AWS, but it's Azure and GCP follow the similar kind of pattern, is that the cloud provider takes care of a lot of your security aspects for you. So they're able to manage the actual hardware itself, including the compute and storage, databases and network, and the software that sits on top of those services. So for example, last year, AWS spent $36 billion on research and development just for 2019. So I guess what we're trying to say is that individual companies, for example, on-premise, are not going to be able to spend anywhere near that kind of money on securing their infrastructure. So the cloud infrastructure is extremely secure. It's just a case of, you can see in the blue blobs above, it is making sure that as a customer, you secure your own data. So the cloud providers give you the tools to do that. There are guides and tutorials on how to do it and best practices to follow, such as well-architected frameworks, which describe how you should design your solutions and what pitfalls there are and which way you should do it. So it's kind of a relationship between the two to get the best out of your cloud platform.
Yeah, I mean, your point earlier about the amount of money that AWS or any of the cloud providers spend on security, because it's key to their business, to their business model, and like you said, it's just not realistic for you know, normal organizations to spend anywhere near that money on it. It's,
no, and this is kind of leading on to, so we go from security to almost to governance. So there's another a phrase that's kind of been coined called a data swamp. So a data swamp is when your data lake turns into something that is too difficult to manage, or to find insight in the data. So how do we stop our data lake becoming a data swamp? Well, that's all around governance. And this is kind of a general pattern that we see kind of followed amongst customers. So it's about splitting your data within the data lake out into specific zones. So for example, we have a temporary zone, which is really just used as a staging environment to do things like transformations and that kind of thing. We have the raw kind of zone where the data is ingested into the data lake in its first instance. So what you would do perhaps is just have access to that zone, the raw zone, maybe controlled only by automated processes, so that you know, customers or users within your business can't actually go in and interrogate that data. Then there might be some kind of transformation on that data where it's moved into a trusted zone. So for example, the raw data might be validated and then moved into the trusted zone. And then once you're in the trusted zone, that's when you can let your data scientists come in and pick up bits of data and do what they like with it, ship it to other platforms or services. Or you can go a step further and perform kind of final transformations on it where it moves into the final zone. And kind of as you move along this kind of pattern, you know, your data matures as you go on. And you use security access controls all the way along to ensure that the right people or the right tools only have access to the right data using that least privilege model.
I guess that goes pretty well onto the next piece.
Yes, yeah. So kind of just the main security features really around data lakes. Obviously the first one is probably access. So how do you control who sees what? So a lot of the cloud providers is based on their core underlying identity and access management features, such as role-based access control. So say your data lake is naturally going to be a kind of multi-tenanted environment where you might have different delivery teams or business units feeding information into it. You might not want your business unit A to be able to access delivery team B's data. So you can segregate that using role-based access control and making sure that only the right people see the right data. And then also another level of that is making sure that subsets of people within those roles can only edit it, whereas maybe only the majority of users can view the data, for example.
I think the other thing is probably worth mentioning at the moment as well, Gareth, is that the level of control you have over that access, because it's not just a case of giving group A access to a table in your data lake or some data in your data lake. You can go down as far as row level control or column level control. So you can actually restrict not just someone's access to a table, but individual rows in that table as well, effectively.
Yeah, very powerful.
Really powerful. Yeah, very, very powerful.
Yeah. And the next kind of line of defense is probably networking. So, you know, these object storage technologies can be made to be private so that you can keep all of your data within the cloud on the cloud's kind of private networking. And then if you want to use services or you want to spin up virtual machines that access that data, then you can do that all along private networking and use firewalls to, you know, prevent public access. So that's another kind of another line of defense there. And then another one is that these services are secure by default. So by default, things like encryption should already be turned on. And this is the cloud providers trying to do that heavy lifting for you. So you can already enable encryption. So anything that's uploaded to the data lake is automatically encrypted, and then set up the kind of mechanisms around that so that when you are doing your uploads, you know, that is happening across an encrypted channel as well. And then finally, another kind of main one is the alerting and auditing. So, you can have, for example, alerts sent to service desks or people who are interested in particular areas of the data lake when someone updates a file, for example, or there's been a download action on a file. And that kind of leads into auditing. So all of these data lakes can be set up to be used with the cloud provider's auditing service. And this just logs every single interaction with the data lake. And you can also alert on those actions as well. So you kind of get a fully, a complete service here with security across the whole data lake.
Okay. So, I mean, we understand a lot now about, what is a data lake, but I guess why, going back a bit and, why are these important? What is it that, where are you seeing these, these technologies being used?
So I guess why a data lake, it's the kind of one we've covered already, is this ability to store structured and unstructured data. So maybe it's a case of that this data you're collecting is important, but you don't quite know how to use it yet. So it needs to be stored, but maybe you'll come back to it at a later point to do something with it. So that's kind of one aspect. Another really big one for organizations that we're dealing with now is this centralized data store. So it's the ability to connect all of these siloed data sources around your organization and get all the data into one area so that you can join data together and perform analysis that you maybe didn't know was available previously by combining different data sets. And then finally, kind of data democratization. So, with the data still in its raw format, that never changes. There is potential to use it for new purposes that you haven't even thought about yet. So maybe you're collecting your data from from different sources and storing it in a data lake. And then 5 years down the line, you think, oh, actually, that data we stored from that project, we could actually combine it with this new project we're running and glean whole new insights out of it, rather than transforming it as soon as you get it. So that's kind of a really big one, is opening up the data to the wider organization and letting people interact with it and use it more.
Okay, but I mean, I guess thinking about who is using data lakes. I mean, is it just a a big organization thing, or is it like anybody could really be using them?
So I've got some examples here, and these are kind of examples that you would see in kind of publications by people like Gartner. So these are kind of industry leading people who are using data lake technology. So for example, the oil and gas industry are using it to do things like optimize their directional drilling tools, minimize unplanned downtime, and lower kind of operating costs. And they're one of the biggest users of data lakes, because if you imagine, they've got all of these kind of drilling devices pumping tons of data into the data lake each day. And so by collecting and bringing all that together, they're able to kind of create models and use machine learning to improve efficiencies. You've then got kind of big government is another kind of newish idea. And this one's more concerned with 5G and how smart cities are going to use IoT data to improve things like, you pulling up to a traffic light and the traffic light sensing your car and seeing if it's safe for you to go. So it kind of, optimizes the best route through town and that kind of thing. Another big one at the moment is life sciences. So data lakes are huge in terms of data science. So you have a lot of data scientists wanting to, experiment with tons of data to be able to do things like genome experimentation, for example. So, there's a lot of really good advances in that. One particular one I read about was that researchers are using kind of data collected from electronic patient records to identify sepsis much earlier than previously by using things like machine learning algorithms. So you're having data lakes, being directly responsible for helping, save lives, which is fantastic. Another big one, cybersecurity. So if you're trying to monitor your estate, that includes tons and tons of devices, servers. Let's feed everything into a data lake and then use analytics to kind of get a hold and be proactive on our alerting and monitoring. And then finally, kind of marketing is an obvious use for this kind of thing. If you imagine someone like Tesco with their club card information, storing that in a data lake to perform transformations and analytics on as well. But I think those are kind of high level, kind of almost idealistic views on how you would use a data lake, but really anyone can use a data lake. As I said, point 2 in the last slide, it's about bringing data together. So a lot of businesses nowadays, whether you're, a company of 10 people or a massive conglomerate, you can use data lakes to bring your data sources together to join that data and perform, a lot of analysis on it.
Sounds good. I mean, I know that we also, have talked a bit about, IoT potentially being a big growth area, and I know that this is something that Nick's got a bit of interest or experience on working on previously.
Yes. So what we found with sort of IoT devices is that you've got various different types. So whether it's a temperature sensor, I think we went to an IoT event that AWS hosted last year, and some of the London boroughs were talking about using IoT sensors for monitoring parking, whether it's on-street parking and people having digital permits as opposed to the little stickers that goes in their windows. But you can generate a lot of data points from IoT devices. So using something like Elasticsearch to collect all that together and store that, where it can be indexed, where you can transform and manipulate that data as it comes in, so it becomes useful the instant it arrives in your data lake, so to speak. I think that's now going to become sort of essential for working with IoT devices. What you're showing there is how the different methods of collection would work. So you can use something like Logstash, where you can use HTTP endpoint and fire that off. It doesn't necessarily have to be coming from a database. It's kind of indexed. It can be all stored together. So even if you've got multiple devices all sending into the same area, you can control who has access to those individual pieces of data, whether it's one particular set of people who are only interested in looking at the parking, or whether it's people who are interested in looking at what's coming from managed buildings. It can all be stored in one big data lake, and then you can control who sees what there.
Well, and then I guess it's, again, this visualization piece seems to always be a key component to then, drive actions from what's happening.
Yeah, exactly. So you can use tools like Kibana, which Elastic provide, which allows you to visualize the data that you've collected. So you can create customized dashboards, and they can be live as well. So it can be updated constantly. So as your data is coming in, those dashboards are updating live. So you can get a live view over, say, a period of time of how the temperature has been changed in someone's house, how much traffic has come through a certain area in a big city. Gareth talked about smart cities. So it would give like traffic controllers the ability to monitor in real time how much traffic is actually coming through, or how congestion is building up in certain areas. And I think that's going to be quite valuable, especially as we've talked about 5G coming along and these sort of smart cities popping up. I think this is going to be quite valuable to those sort of city planners and sort of keeping cities moving as we sort of get more and more traffic on the roads.
Yeah, and I guess these real-time visualizations of kind of painting a narrative of what's happening. When you look back at some of the the older technologies, where everything was processed in batch, so it wasn't really possible. You would either be having to run a number of like continuous compute jobs to get as near to real time as possible. But I guess with some of the newer technologies that actually allow for streaming of data and real time reporting and visualizations, again, I think that's going to change the way that people interact with the data that they're storing in their data lakes.
Oh, absolutely. I think people see sort of like traffic surveys being conducted in the past where you'd have someone actually sat to the side of the road watching the traffic. Well, he's collecting that data, but at some point he's got to then take that away and then analyze it. Whereas now it can be done as it's actually happening, not a day or a couple of hours after the event. It can actually be collected and analyzed as it's happening. It's gonna, I think it'll revolutionize the way that sort of the smart city works.
I mean, I know, obviously we talked a bit about, Elasticsearch is like not an alternative, but, a different technology that also kind of fits in this space for, I mean, we've seen it for IoT use cases. I know we also use it a lot for cybersecurity type use cases as well.
Yeah, so I think looking at sort of cybersecurity for an example, you're going to be wanting to collect a lot of logs from various different sources, from operating systems, from network appliances such as firewalls, and you're going to need to pull all that into a central place where your cybersecurity teams can view that data and analyze it. One of the things that Elasticsearch does is it can take all that log information coming from different types of Linux operating systems, your Windows operating systems, your network devices, firewalls from various vendors and such. It can bring all that information into a single place where your cybersecurity teams can have a single pane of glass that can give them an insight into what's going on in the environments. But one of the good things with Elasticsearch is they've kind of recognized the potential for this. So they provide an out-of-the-box solution for collecting this information. So they have something called the Elastic Common Schema, where they can take all these different log files and they can apply a common schema to log files being generated from different sources, which are essentially in different formats, format them so they are uniformed, and then present them in dashboards, whether it's the built-in scene dashboards or whether it's dashboards that cybersecurity teams want to create themselves to actually analyze this data, and they can see it. And again, we talked about real time. This is all in real time. You can see attacks on your network happening in real time, and using the machine learning technology that's built into Elasticsearch, you can be alerted to an attack within seconds of it starting. It's more not sort of going back and looking at, oh, did we have an attack last week? It's we have an attack right now, and we can see where it's coming from. We can see where they're hitting, and we can even see what they're trying to do, and we can shut it down. And not, it's more about sort of being able to shut that attack down there and then, as opposed to going back and looking at what happened and how it happened, and then sort of stopping it from happening again. They can stop the attack first time.
Yeah, I guess, the old way of doing it was kind of the attack happens, you have the post-mortem, and then you put in fixes to try and prevent it. Whereas, now these technologies are letting you see it happen in real time and prevent the attack or prevent the threat before any real damage is done.
Yeah, and you can actually, cybersecurity teams can be alerted to these attacks before even the user of a laptop who got attacked turns on to cybersecurity and says, I think someone might have done something to my machine. They can actually turn around to that user and go, someone's doing something to your machine right now, and shut it down. It's almost a different world from a cybersecurity perspective in that sense.
No, I mean, it sounds, to be fair, it kind of just sounds like how you think things should be, but
yeah.
often in IT, it's things are often more difficult than they should be. So, but no, I mean, really good use case there. So I guess one of the final bits to talk about is costs. You know, and when we're talking about costs on data lakes, we're obviously talking about the on-premise cost versus the cloud cost. Sometimes I talk with customers and they worry about spiraling costs in the cloud. Because of course they're collecting so much data, but then I guess Mark or Gareth, there is also a cost for having that data on-prem.
Yeah, I think some of the figures I've seen recently. I just jotted some stuff down which I saw a little while ago, and they were talking about basically if you had something like a Hadoop cluster with a couple of management nodes and maybe a bunch of data nodes. Looking at the network components, the one thing that we tend to sort of forget about a little bit, I think, is hardware support as well, which is something that sort of comes off the bill when we put things into the cloud. It was looking at sort of an example of where for a 5-year period for that sort of cluster setup, on-prem, they were estimating that it was around about $12,500 to $13,000 per month. Comparing that with exactly the same sort of setup in Azure, I think it was at the time, and they were looking at getting that down to between $10,500, and that was the basic pay-as-you-go price without any discounted enterprise pricing or reserved instances pricing or anything along those lines. So yeah, I think that's a couple of $1,000s a month, which obviously that frees up some of your budget for looking at now some of this data and looking at the improvements that can be made by using it this way.
Yeah, and I guess it's also what we were talking about earlier, the opportunity to experiment. You're not committing yourself to a big upfront capital cost,
Absolutely.
Cost. You can experiment more. The time to go live is quicker as well. From I mean, standing up a Hadoop cluster. I mean, I know some of you people, some of you guys will remember the days of waiting for tin to arrive and sort of fitting it into racking in the data center and making sure your cooling's there and everything else, and just vendor lead times. Whereas, with all of these on-demand services, it kind of does that for you. No waiting around, just kind of come up with the idea, prove the concept, and get on and go.
And as more and more people are using these services, I mean, we've seen it with storage in particular, but also with compute prices. Is as new technologies come out, Amazon are tending to and Azure are putting those cost savings through to the user basically immediately. It's not a case of next time we buy some disks they'll be cheaper. It's from today our disk utilization prices are going down, and you will see a saving from today. And there's a lot of competition, obviously, between the big three players to make sure that they are the most reasonable priced, or the best bang for your buck, if you like, in each of these components and areas.
Yeah, I mean, if you're looking purely at data lake storage, so it's as cheap as 2 cents per gigabyte per month. So you're paying barely nothing to store this data in the cloud, and what is not a headline figure is that when you're storing that data in the cloud, you're getting a ton of cloud benefits for free. Things like the redundancy and resiliency and high availability that it provides.
Okay, well, really good. Normally we would try and leave some time for some questions and answers, but I mean, we've got maybe 10, well, maybe 20 seconds left. So if there are any questions, or if you want to talk to any of us about any of the topics we've discussed today, please feel free to send your questions into info@mobilize.cloud. Other than that, just want to say thank you for joining us. I mean, we hope you found this useful. and interesting. You know, it's a bit of a different format for us, a bit more informal, but hopefully, you know, kind of giving you a bit more of a feel for, you know, some of the things that we're experiencing and some of the use cases that we're seeing and how we're implementing data lakes and other technologies to, you know, to solve business problems. But other than that, yeah, I'm just going to say, you know, thanks for joining us, and yeah, hopefully we'll see you again on another webinar soon.
Thanks, everyone.
Thank you.